clicker work? Yeah, there we go. Hi, I'm Fritz Kunstler. I am a principal security consultant. Been with AWS for about 7.5 years now. And I would say, I don't know, maybe a few years ago, I started with some colleagues doing some experiments around how we might be able to apply data science and analytics to help customers strengthen their identity and access management. And that ultimately led to work at the intersection of generative AI and security, which has been my focus for about a year now. And I'm really excited to talk to you about that today.
I'm Anna McAfee. I am a senior security specialist solutions architect. I've been at AWS about 3.5 years. Before I joined, I worked as an AWS customer in a variety of security roles, incident response to red teaming, that kind of thing. And recently I've been focusing on generative AI and how our customers can use it to really make security better and hopefully easier. So looking forward to speaking with you guys today.
Marshall Jones. I've been at AWS roughly 4.5 years in a couple different roles, professional services as a security consultant, last 2.5 years as a security SA. My background's in threat detection and incident response as well, and I essentially spend most of my time now helping customers adopt the native AWS security services and building and operationalizing them.
Cool. So whatever your job, the fact that you are here with us today and thinking about this topic means that you are a security leader. And leaders recognize that generative AI, like cloud, it's a powerful technology, and it is going to change the way we work. That is already changing the way we work in some cases. With that in mind, it's important for security leaders to ask, how can I minimize the fear, uncertainty, and doubt around this technology and use generative AI to drive better, faster, safer security outcomes for your organization? And we hope to help you answer that question here today. Now, generative AI and security are obviously both very broad topics, and so we're going to start with an explanation of the specific opportunities and challenges that we're going to cover in our talk today. Then we'll walk you through the use case for our virtual security assistant and do a quick demo. Next, present our solution architecture, followed by some detailed demos, really get into the nitty-gritty of it. And then we'll share some resources that you can use to do this yourself. And if we're lucky, we get the timing right, we'll close out with Q&A. But first, the bottom line. We're going to share some really cool and interesting things here in just a minute, but if you really only remember one thing from this talk today, I hope it'll be what's on this slide. So in our opinions, AI is unlikely to replace skilled security experts anytime soon. But you do want to get smart on this technology because individuals and teams that make effective use of generative AI will outperform. In other words, AI is probably not going to take your job anytime soon, but someone who is making better use of AI than you, well, they might. AWS services like Amazon Bedrock and Amazon Kindra are serverless experiences that make it easy to get started and to keep your data private and secure. No customer data is used in the training of underlying models in Bedrock, and your data is encrypted, secure. It does not leave your VPC. Additionally, you can deploy, integrate, and secure your generative AI application using familiar AWS tools and capabilities like the AWS CDK, Private Link, AWS Identity and Access Management, KMS, WAF, and more. This technology, generative AI, it's not magic, and you don't need a PhD to build with it. In fact, as a general purpose technology, generative AI is much easier to use than many of the earlier specialized ML models. And with Bedrock, using your choice of foundation model or large language model, it's just another API call. You can get up and running in a matter of hours, and we're going to show you how.
Awesome. Well, so I want to get started and think about how much there is to generative AI security, and want to kind of clarify what we're going to cover today. So first and foremost, security of generative AI. These are the applications that actually use it. This could be things like the controls you have in place around, public chat applications, public generative AI applications, or just exercising your opt-out mechanisms. These are kind of your risk management type things. Then next we have security from generative AI threats. And if you're not familiar, OWASP actually recently released a new top 10 that goes through threats like prompt injection, like training data poisoning. Super interesting topic. And what we're actually here to focus on today is this last item. So definitely a lot to these first two, but I just wanted to at least clarify that we're focusing on this last aspect. How can you use this emerging technology to make your lives easier? So I suspect if you're here, maybe you're a developer or you're a security professional who's interested in how can my life be easier. So we really want to focus on that aspect today. So how can you actually do that? I think that there is kind of a number of ways that we believe that you can achieve strengthening security with generative AI. So to start, automating mundane tasks. I know if you're like me, one of the boring parts of your job is reporting or summarizing information. There's a lot of opportunity with security professionals to automate those types of tasks. Next, expediting your decisions and operations. So say you guys get a security finding, whether it's something like a threat detection, we think there's something in your environment that's going on, or a configuration risk. You may want to have a playbook that's in place. Well, how do you write those? And you may say, we're a group of 5 people, I don't have time to write the playbooks. This could be an opportunity to say, if I get this finding, how would you write it? And then you could actually use generative AI in that space to write and run these playbooks. And then lastly, just increase focus on interesting topics. So hopefully, after this, you can take some of these like mundane tasks, like reporting. You could focus on these novel problems. So your security SMEs could really focus on interesting and high-value opportunities. So I know hopefully you got excited about how you can use generative AI. We definitely want to at least explain some of potential pitfalls, and then we will go through how to mitigate these. So I want to first start with saying we're saying here a public AI chatbot service. So nothing that's custom, but we want to say if you guys were looking for security advice, what would this look like? What are some of the risks? So I am a developer at a company, I use AWS, and I need help. How do I secure my application? Well, if you go to some sort of, public chatbot, they may say, okay, Anna, I need your company's security policy. That would help me actually help provide guidance. And if you are a customer, what you might say is, I don't want to provide that information as a company to a public chatbot service, which is a totally fair response. And so would a public chatbot say, they may respond with maybe an assumption or speculation. So this is just a pitfall of using some of this, but again, I still feel like there's a lot of opportunity in the space. We just want to recognize what could happen, which is a public one without the proper layering on top of it. So I want to dive a bit deeper into these considerations. So to start, if you're not familiar with hallucinations, what is this? This means a model is providing a response, but it's just incorrect. So say you're going, and this is one thing I personally do, is I'll be like, I want a travel itinerary. I'm a busy person. I would love for generative AI to figure that out for me. Not the end of the world there if they're wrong. But there obviously are spaces where you want to make sure that's correct. So we just need to consider hallucinations and think through how this affects things. So, and we will kind of go through some of the keeping humans in the loop, that type of thing. Next is data privacy. So we're going to go through a RAG architecture. I know we're introducing RAG here. We're going to dive deeper into that. How do you keep sensitive data out so to ensure that, maybe not everyone should be able to say, what's the biggest risk in my environment, right? You want to make sure that that data is, closed. And then lastly is quality control. So this is still a human in the loop operation, right? So, given the current state of the art with generative AI, the human in the loop must review these outputs to make sure that they are high quality and validate that the output, is sane and matches the source data. So that's an important aspect to this.
All right, so let's start with a scenario. Anna, you talk to many people as a security SA. Here we go. We talk to many people as a security SA. What's one of the common kind of scenarios that you hear about?
Yeah, so there's a lot of different scenarios, but I think the one we want to go through is I need an IAM strategy, and it's just like my IAM is not scaling well, and it's becoming a blocker, it's slowing us down. What do I do? How would you respond to that from an AWS security consultant perspective?
Yep, Fritz, you've got an IAM background. What's probably your most natural response when a customer says that to you?
Well, first I would say this is a very common scenario, particularly where adoption started organically and then scaled out in a hurry. And what we'd say is that, first let's take a look at your delegation model and your workflows, and then I can work with you to develop a new IAM strategy, and that's something that could take around 6 weeks.
And my response would be, what you guys would think is, why does it take so long?
Yeah.
I need to get this done. I need an IAM strategy tomorrow. What's the blocker?
It's not so much a blocker. I mean, the fact is that a lot of analysis needs to be done in these situations. We need to understand the current state of your environment, all of your organizational security policies and the associated documentation for that. Then we might need to go talk to some teams to have them show us the way they've implemented things in their individual AWS accounts so that we can create a roadmap that's prioritized appropriately and actually feasible to implement. And the bottom line is all that takes time.
Great. So with that scenario in mind, we'll just discuss. Now we're going to have a similar conversation, except with a generative AI chatbot that we experimented with and built for this talk, and see what this conversation looks like. One thing is, I promise we're going to get into the exact details of how we did this further into this talk, so bear with me. All right, so we're essentially going to start out by asking the exact same question. Essentially, my team's approach to IAM isn't scaling well, and it's slowing us down. Can you help me with an IAM strategy? We're going to ask this pretty basic question, see what it gives us. So it's going to start generating some suggestions. As you can see, it's bringing some things back. Use roles instead of users whenever possible. Sounds like a good idea. Use groups to assign permissions to sets of users with common access needs. Leverage levels to define permissions based on job function like developer and analyst. Automate provisioning and deprovisioning. Use temporary credentials. Monitor this activity with CloudTrail. Regularly review and role definitions and policies and resource permissions. And then it also says the key is starting with least privilege approach and leveraging automation. So if you've got a little bit of an IAM background, this sounds like some pretty good advice that's been given to us so far. So based on that, we'll probably have more questions, right? We're gonna wanna ask a follow-up question and just see what else what other information that we can get from this. So as we go into this next question, we're going to add a little bit more, we're going to look for a little bit more context that's specific to our environment based on the suggestions that I gave us before, sticking on that strategy of least privilege. So now we're just saying, following up with that question, based on my strategy above, are there any security findings in my environment? So any security findings in this demo environment that we built that we should prioritize based on the suggestions that were given above. It starts to provide some information back. Based on the information provided, it seems the top priority would be to address the finding that an IAM policy allows full administrative privileges. So the recommendations suggest following the principle of least privilege, once again staying along the theme that we saw from the suggestion above. And if we look at the third and fourth column, it gets a lot more specific about our environment. So we're essentially addressing this finding by reviewing and restricting the demo everything policy, IAM policy, to only grant required permissions would be the top priority. The other findings related to ensuring IAM policies don't allow full admin access, but are also important, but the demo everything policy seems the highest risk right now based on the information provided. So now we can see we got some suggestions and some information from this, but then we are also able to use this to get context that's specific to our environment to go now take action and improve the security posture of what we built here. So as we get into this a little bit more, we wanted to build some tenants as we were building out this experiment in this demo. If you're not too familiar with tenants, tenants are fundamental at AWS. So every team, every project has a set of tenants, and they rely on them to make tough decisions, right? So if I'm working on a project and I'm trying to decide whether or not I should make a decision one way or another, I can always look back to the tenants and think, does this go along with the guidelines that we've set out for this project or for our team? Does this align with what I should be doing? And then really make my decision based on that. So building some tenants for this application, we wanted to make sure that we use responses as inputs to a process and not authoritative guidance, right? So we should look at these, and we should also consider other contexts that we know about as humans, and not use it as authoritative guidance, but use it as inputs to any decisions that we're going to make. It rolls into keeping a human security expert in the loop, right? If you're security experts at your company, a lot of you are probably in this crowd, you've got understanding of people, process, and technology, either benefits or constraints that exist at your organization. So it's important to understand these things when you're getting outputs and getting information and context or suggestions from this generative AI application. Protect and verify knowledge-based content used in RAG providers, and like we said, we're definitely going to dive a lot more deep into RAG providers and the benefits that provides. But essentially, think of this as garbage in, garbage out. You want to make sure you're providing context that's going to be helpful to your use case and what you're trying to accomplish with this, right? If you're feeding it any and all context, you might not be getting the best results out of this. So keeping context clean and understanding what context you're giving is important when you're working with this. So devise automated and manual tests to continuously validate and improve answers over time. So think about a progression over time of building out a generative AI application, and you're going to want to give it more context about maybe internal policy documents or other public documents that give great context into your different use cases. You're going to want to continue to validate, either through manual or automated tests, that context is helping and driving better answers and better suggestions and better context into this application, and not degrading anything that you've built so far that you're trying to improve on.
All right, before we get into the technical architecture, I want to return for a moment to a point that Anna made earlier. This is similar to a previous slide. So we got really excited when we saw the first results out of this experiment we were doing. And to be clear, this is an experiment, right? Like we're not talking about a full-blown service here. the results actually look really good. But without access to proprietary information, a large language model can only respond based on its training data. And sometimes that might be really good and convincing information. In fact, it is true that the capabilities of pre-trained LLMs, like the one you saw in the demo here today, which is Anthropic's Claude V2 model, the capabilities are truly amazing. But for a security application like ours, we cannot assume that the model's response is always going to be appropriate and accurate. And that could be for several different reasons, but one that we're particularly concerned about is the idea of hallucinations. And all large language models are prone to this problem of hallucinations. That's basically where the model responds with erroneous information in an authoritative way. So if the output is not reviewed by a subject matter expert who can really differentiate, you can end up in a situation where bad guidance is being given and used, and if that is being used to secure your environment, obviously it could lead to bad outcomes, especially over time. So there are several techniques that we can use to minimize that risk. And it's not just about the risk of hallucinations. There's other factors too, but there's several techniques that we can use here. And they're all basically about doing the same thing, and that is to provide context to the model along with the input that we're giving it in the form of prompts in order to ensure that the answers we get back, the information we get back are specific to our environments, to our organizations, to our use cases. Prompt engineering is the basic technique, I spent a bunch of time trying to figure out how best to describe this, but long story short, it's just about iterating on the questions or inputs you provide until you get them optimized to the point that you get the best answers back. One way to think about this, if you are a native English speaker, like I am, in elementary school, at some point, some English teacher said to me, I would ask, hey, can I do something? Can I go outside? Can I go to the bathroom? And she would say, well, yeah, you can, right? So I can ask the model, can you write me an IAM strategy? Its answer could just be yes. That's not really what I'm looking for here. So that's the way I like to think about the prompt engineering story, like really getting your inputs optimized to get the answers you want. Now, a level above that, RAG, or retrieval augmented generation, which you've heard mentioned here several times, that's one way to customize the outputs from a general purpose model to perform domain-specific and business differentiating functions, in our case, security ones. And the thing about RAG is that using that method, you can achieve those things at a tiny fraction of the cost and time required to train a custom model, and even cheaper. So in between the two, there's this other option that you see listed there called model fine-tuning, and you can do some really interesting things with that. But we're not going to go into it right now because we didn't find it necessary in order to achieve the outcomes we were after for this demo and for this topic. So the demo you saw a moment ago is an example of a RAG application. Again, RAG, or retrieval augmented generation. To produce those answers that we got, right, we weren't just relying on the base model and its training. So to produce those answers we got, our virtual security assistant needed to know three things. First, it needs knowledge of our organization's specific security policies, standards, control frameworks, et cetera. And for the purposes of this demo, the stand-in we used was the AWS security reference architecture. Second, the technical knowledge, it needs technical knowledge of the target systems. And in this case, the targets were AWS identity and access management and related service documentation. So that's those documentation packages are how we gave the model the technical knowledge it needed. And then third, it needs knowledge of the current state of security in our AWS environment. And you saw this reflected in the fact that when Marshall asked a follow-up question, he actually got back guidance about a very specific role and policy that needed attention, right? So obviously the model itself is not going to have that information at hand. The way that we handled this for this demo was to use findings from Guard Duty and from Security Hub that we extracted from Amazon Security Lake. So now that you know what information we need to provide to the model as a context, I want to dive a little bit into exactly how that's used in a RAG architecture application. Note that we're using Kyndra in this diagram as our RAG provider, but this flow applies to any RAG provider. Kyndra, it's not, it could be just about anything. So first, our end user makes a request, and in the case of our demo application, that looks like typing a question into the chatbot. Second, our generative AI app, again, the chatbot in this case, takes that question and formats it into a query that it sends to Kyndra using Kyndra's retrieve API. Third is going to be that Kyndra then responds by returning relevant excerpts of documents from the index. Now, these documents would be ones like I mentioned on the previous slide. So these could be your internal, like proprietary security policies and standards and guidelines. Could be control catalog like NIST 853, AWS technical documentation, et cetera. But all of that could be in there and part of the excerpts that come back. Fourth, our generative AI app in the middle there is going to send the original user request along with the excerpts it got from Kyndra as context to the large language model. And the parameters, in this case, that we send along with that stuff to Bedrock say, in effect, Bedrock, you must answer the question being asked here from the context provided. And if you can't do that, you have to say, sorry, I don't know. We're not going to let you make up an answer in this case because the stakes are reasonably high if we're going to use this for security purposes. So then ideally what happens is the LLM comes back with a succinct response to the user's original request based on the provided context. And finally, our generative AI app is going to format that and send it back to the user as a reply from a chatbot, just like you would see in a typical chat conversation. So this architecture may look familiar because there are so many examples of it out there, probably a bunch of them in your organization too. I mean, this could be pretty much any serverless app of any kind deployed on AWS, right? And we're showing it because I want to make the point that all I need to do is add that Bedrock box to this diagram, and now I've got the architecture for a generative AI application. When I realized that was that was really powerful realization for me personally. My own background is not in AI ML; it's in security, and so when I realized it was potentially this easy to do, that was pretty exciting. And now that previous diagram is a bit of an oversimplification, right? This is the actual architecture diagram that reflects our virtual security assistant. It's pretty close, but you could see that we have added on the far right-hand side there a couple of RAG providers. In this case, Kyndra, which I mentioned previously, as well as Amazon OpenSearch, and we'll talk a little bit about that in a moment, as well down below Security Lake, which, as I mentioned, is the source of the findings data we use to provide the context about our the current state of our environment to the model. So why those RAG providers? There are lots of options for RAG providers out there, and no single one, this is just like any other kind of technology practically, right? No single tool is likely to solve all RAG use cases. There are a few specific reasons why we chose Kyndra and OpenSearch Serverless as our RAG providers. So for Kyndra, The available connectors to common enterprise knowledge management systems are super valuable. There are a bunch of them. I don't know, I don't remember how many, but it's dozens for sure. And they make it really easy for you to ingest proprietary security documentation, or really anything else for that matter, from your existing enterprise knowledge management systems without writing any custom code. That's really valuable. And you're going to see how easy it is to set up in just a moment here in the demo. And OpenSearch gives us a high-performance, scalable, and cost-effective vector database, which is great for indexing the findings data that we extracted from Security Lake, which is more structured than the typical documentation use case that we rely on Kyndra for. And, well, I guess we're about to show that to you now.
Got to use two hands. All right, so let's jump into, like I said before, we're going to show the entire configuration of that chatbot that you saw earlier. So you're going to see every little detail and then some of the different configurations to get that chatbot set up. So let's go ahead and get started there. The first thing we're going to do, this is on GitHub, and we're going to share a link later, but we do a git clone. Change our directory to get into the actual directory. We're going to do a couple build commands here. So we're going to do an npm install and npm run build. It's going to build for a few seconds. And then once this builds, we're going to actually set up the configuration for the chatbot. It's going to ask us a few different questions that we'll go through. And one thing to note is all of these kind of steps are on that GitHub page as well too. So next thing is we'll do the npm run create, and this is the configuration process. We're gonna give it a name. I'm gonna call it SEC210. We're gonna say yes, we have access to Bedrock. We're gonna just go ahead and use US East 1. We're gonna use the standard Bedrock endpoint. We don't need a cross account role because we did it in the same account. We're not gonna use any SageMaker models for this, but it's something you could easily add on. Do you want to enable RAG? We're going to say yes, and we're going to select OpenSearch and Kyndra. We're going to let the chatbot create these for us, and that's what we're selecting here. It's also going to ask us if we needed a Kyndra index, or if we already had a Kyndra index, and we said false. And then it says, do you want to confirm this configuration? And we say yes. So next, we're going to do an npx CDK deploy. If you haven't used the CDK or cloud development kit, essentially it's going to deploy a CloudFormation stack in the background, and that's what you see going on here. So those resources that we talked about earlier, the Lambda functions, CloudFront, Cognito, all of that's going to get set up now. And this whole setup, I think took me like 45 minutes or so to set up. So we've accelerated that process here for this demo. But it's essentially going through and creating all of that, and also those RAG providers, so the OpenSearch serverless cluster, the Kyndra index, and then after the deployment finishes, we'll jump into and work on setting up the configuration that we need to do there, as well as the rest of the configuration in the actual chatbot itself. Cool. So I think the total time was 1,700 seconds, as you can see there. And now we're going to switch over to the Kyndra console. We're going to go to indexes. You can see the index that was created for us. We need to add our data source now and tell Kyndra what we're going to go index. You can see the different connectors that Fritz mentioned briefly. Jira, you can see some of these maybe internal tools. We're going to pick a web crawler, and we're going to give it a name for this data source. As you can see, I love dashes, and I will continue to use them as we walk through this. So SEC210-IM docs. We're going to use a sitemap, and we're going to put in the sitemap for the IM documentation. And then I'm going to leave everything else as the default. I'm going to let Kyndra create the IM role because I'd rather let Kyndra create the IM role. Once again, give it a name.
Huge dash guy.
Big dash guy. Well, so we say next. There's some additional configurations to consider here. I leave everything as default, but there's crawl depth, for example, that, how deep do you want to go in that documentation? How often do you want this to be crawled and indexed? Depending on how the documentation and how often it might be updated is really going to depend on the crawl depth. So there's some other things to consider, certainly, when you go through there. I'm going to go ahead, I click Add Data Source, and it's creating an IAM role, so roughly it takes 30 seconds or so. We sped this up a little bit.
We may not have sped it up quite enough.
Yeah, we're learning that. So, all right, so now that we have our data source created, like I said before, I put run on demand. So essentially, now we're going to sync. And if you can read that tiny lettering at the top, it says a few minutes to a few hours. In our case, we're crawling and indexing the IAM documentation, which is rather large. So ours was closer to the few hour mark. So essentially, we let it scan and scan and scan. Goes on and on. And then you go to lunch and you get your wallpaper screen. And then when you come back from lunch, it will be done. But before we move on there, the next thing we're going to do, you come back from lunch, Kendra's done indexing, you're all good to go. The next thing that we're going to do is we're going to go grab some security data from Security Lake. If you're not too familiar with Security Lake, it's a managed security data lake. It stores security data findings and logs in S3. For this demonstration, we essentially just go grab some of this data that we can provide and put in OpenSearch fairly easily. And we're going to do that with Athena. So I'm using Athena to grab some data from Security Lake now. So essentially going to run my query. We're just looking for data over a day. We see there's some Security Hub and some guard duty findings. I'm just going to download that CSV. Let me pause it correctly this time. I'm jumping to the next part, which is essentially the CloudFormation console. So the reason we're going here, I told you before, CDK deploys that CloudFormation template in the backend, so you can go and get the output. In the Outputs tab of that CloudFormation stack, you will see the URL for the user interface. So we want to go ahead and grab that. And then as we jump to that, I do want to say that I did skip one step as part of this, and that's essentially setting up the create user incognito. You essentially just create a user, and then you have to reset your password on the first login. And then once you do that, you'll get into the chatbot, and it'll look exactly as it looks here. So we're going to finish the configuration of the RAG providers. On the left navigation pane, we're going to select workspaces under the retrieval augmented generation or RAG space. As you can see, we don't have any workspaces. We're going to create a workspace. I first do the OpenSearch serverless workspace and give it a name. This is where we're going to put our Security Lake data, like we said before. So security-lake-data. Look at the additional settings. We're going to keep all of those default. And then we're going to click Create Workspace. And then it takes a second to create. So in the meantime, we'll create the Kendra workspace. So we select Kendra. We're going to name this IAM-docs. If you remember the demo from earlier, this was at the bottom of the screen. We select the Kendra index that was created, and we'll select Use All Data. And then we'll select Create Workspace. So now we got to finish the Security Lake data. We went and grabbed some security findings with Athena. Now we're going to actually upload that data directly into the chatbot, or into OpenSearch that was created through the chatbot. So we'll select Choose Files, and we'll choose that CSV file from the Athena output that we grabbed earlier. And then we'll upload, and then once it's all complete, we can carry on. So one of the first things that you probably think is, or want to do next is go test that this thing works.
Well, luckily now that it's deployed with all the errors, hopefully now that it's deployed, there's no issues with the demo. So thank you all for your patience with that. So I know we showed briefly earlier this chatbot, and now we know how it's deployed. I want to kind of go back and let's ask some questions. Then we're also going to show some of the metadata and some of the back end, hopefully get you guys to understand some of the items that, and the decisions that we made that are here. So we're going to start with a simple question here. So what are some of the best practices with IAM roles? So as you can see here, and I'm going to pause, and hopefully I have better luck than Marshall, where you can see these are definitely like valid responses and things that are valuable. Using least privilege, having temporary credentials, using identity federation. These are definitely best practices for IAM roles. So, but the next thing, let's make this a little bit harder here, right? So we're gonna ask around how you would use, how you would do, actually implement IAM, like an implementation strategy here. And so one thing that's interesting, and when you look at this, is you can actually see there is, at least in a response, and this is something you would, I would say, want in a way to say, okay, I need more context. And so I'm going to pause here, and so we can actually look through it. And it says, I don't have quite enough context. It still does provide interesting and relevant information, and I think that's really important. And so one thing I thought was interesting that Fritz mentioned earlier is the aspect of the prompt. So here we said, can you? I think that the prompt engineering here does play a role in how you're actually asking these items. And again, I want to note down here, when we're working with this chatbot, right now you can see we have no RAG data source. So we are gonna quickly flip so you guys can see what this would look like with a RAG data source. All right, there we go.
There we go. Yeah.
Got nervous there. So now that we're thinking about what IAM issues do I have in my environment? We've added this security lake as a RAG. We want to understand the issues that may exist. We now have that contextual information that Marshall showed we added, and we should get a response that now understands our environment. So as we look at this is important. We can understand, okay, we have an IAM policy here that grants full administrative permissions. We also have, a certain account number that they're calling out. We're getting prescriptive guidance on things you need to change from this chatbot. We're now switching to this multi-chat option, so you guys can see the difference between one with a RAG provider of Security Lake and one without it. So we're going straight to the LLM on the left, and then we're adding that RAG provider on the right. So we're going to see on the left, we actually have the information, okay, I actually don't have the correct information to fully answer your question. It's telling us, we don't have information about your environment. I can't really tell you what is the IAM risks there. On the right, it's actually telling us. So you can see the difference between the RAG data source and the just plain LLM. Now we are actually going back to the chat, and we're just saying, provide me a link to the IAM documentation. The reason why I'm showing this, I actually want to show you guys, we're going to show some of the metadata around the calls that actually exist. And from here, you can see a little bit towards the back end, what's going on? How are they making these decisions? How are they providing these links? And so what you can actually see here is various page content. Here are the various things it was looking at, various paths, the content on these. So for the sake of time, I'm not going to go through and bore you guys each of these, but I did want to show that you are able to at least get some insight how these applications are making decisions. So I know, we kind of jumped all over the place a bit with the demo, but I want you guys to at least hopefully see how you can use this as a job aid for security. Whether you're one person in security on your whole entire organization or you're, a massive organization, it can really help. And so I hope you guys at least saw some of this is how you can use this to make your life easier and move quicker. So.
Right, back to some key takeaways here. So again, our opinion is that AI is unlikely to replace skilled security experts anytime soon. You can see from this demo, this is, by the way, this is all real, there's nothing synthetic here. We actually did everything you saw. And it's pretty impressive as far as technology that you can deploy in an hour goes. But it's not going to replace any of you as security experts anytime soon. Again, you do want to get smart on the technology, though, because it's easy to see how teams that are using it effectively can, in pretty short order, outperform ones that are not. Oops. AWS services like Amazon Bedrock, Amazon Kindra are serverless experiences that make it easy to get started and keep your data secure. There's not going to be any, with Bedrock, none of your proprietary information, no customer information, period, is used to train the underlying models, and your data is never going to leave your VPC, so it's safe. You can also deploy and secure the generative AI applications that you want to run using these tools in the exact same way that you're deploying traditional applications on AWS today and securing them. So we're talking about things like CDK and AWS IAM and KMS and WAF and the like. Finally, this technology is not magic. And as I said before, you don't need a PhD to deploy it. You can do this. You should experiment with it. Not only for the sake of your own security team and increasing your security team's performance, reducing toil on mundane tasks and all that kind of thing, but if you're responsible for the security of your organization, the sooner you are experimenting with this stuff, the easier it's going to be for you to help the business units or others inside of your organization make smart security decisions about the applications that they build using this technology. So we certainly encourage you to get started experimenting with it as soon as you can. And if you're interested in doing that the easy way or uneasy way, you could scan this QR code. That's going to take you to GitHub, which has the demo chat application that we showed you today. We did not write that chat application, just to be clear. We're not taking credit for that front end component. Another team within AWS did that. Just to be clear, but you can get it and you should use it. It's a fantastic piece of open source technology. Just quickly, there are a bunch of people who aren't on this stage today who contributed to this talk, and without them, we would not have been able to stand here and tell you all about it. So special thanks to the folks you see mentioned there. In case you're not familiar with AWS Reinforce, it's our annual security conference. And in 2024, it's going to be in Philadelphia, and we hope to see you there. Thank you very much for your time. If you would like to contact any of us, you can see there how to do it. We'd love to hear from you. And I'm watching this clock below me, which is down to 45 seconds. That means they are not going to let us do any further Q&A from the stage. But you could find us back there in the back corner if you have questions. We'll be happy to hang around for a little while and answer them as best we can.
Thank you.
Thanks very much.
Sure, bud.